Welcome to lesson 1.6. We're going to be talking about powers of 10, and scientific, it should say notation. That word is missing. So we need to write the word notation. For some reason, that one got missing. So we have three sections to this lesson. So we have A, powers, B, powers of 10, and scientific notation. So when we talk about powers, when the same number is multiplied over and over and over again, we call that repeated multiplication. So if you take a look over here, we have repeated multiplication in the table. So you're going to see 3 times 3, we get our answer 9. 3 times 3 times 3 gives us 27. And 3 times 3 times 3 gives us an 81. Now, is there a simpler way I could write those? Who remembers how to use powers? Anybody remember from last semester, anyone? Yep. No? Okay. So whatever number is being repeated, that's the number called your base. So these guys all have a base number of a 3. Now, however many of them you see, however many number 3s are being repeated, that's the number that's going to go on the top right, little baby. Okay, so it's going to be a little baby number on the top right. Okay. So how many 3s do you see in the first chart? In the first one, how many 3s? 2 of them. So I would put a little 2 on top like that. And in the next row, you see 3 3s. And in the next row, you see 4 of them. Okay, so that little baby number on top, he tells you how many of those base numbers you're going to multiply by itself. Okay, that's what that's talking about. Okay, let's take a look. They're doing the exact same thing with the number 4s. Okay, and however many 4s you need. All right, moving down, it says another way of writing repeated multiplication is by using powers, which is what we showed right up here. So the big number is called your base number. That's the number that gets repeated all the time. The little baby number is called the exponent number, and it always has to sit on the top right. He'll never be on the left. He'll always be on the top right. Now, the whole thing all together, all of this all together is called the power, okay? So there's a different way we can say it. So I could call this guy 4 to the power of 2. I could say 4 squared. Or I could say 4 exponent 2. Okay, so there's different ways we can use words to describe what we're doing. Okay, now the number 2 and the number 3 have specific names. So the number 2 can be called squared and the number 3 can be called cubed. So it's because we're dealing with real life objects, believe it or not. So I will describe that on the next page in a moment here. So first of all, we want to know what these definitions are. Well, they're telling us the base. What is the base? Well, the base is the big number that's being repeated. Okay, so it's the one that is multiplied by itself over and over again. Okay, so it's the number being repeated. So you might want to write that down. The number repeated. Now, the exponent, that tells you how many of those base numbers to use. So it's actually got a job. It's like, hey, number 4, multiply yourself twice. Okay, that 2 is telling the 4 something to do. Okay, so that exponent represents the number of times we multiply the big base number. And the power is known as exponential form. That means we're writing it in short form. If we wanted expanded or in repeated multiplication, that's what that would be called. Okay, expanded form is the repeated multiplication. Okay, looking at the next page. So it says we've got repeated multiplication right here in front of us. So this is showing our power, and then it's showing the answer. The answer is also known as standard form. Standard or decimal form. Why do you think decimal form? We discussed that a few days ago. Do you remember why anything can be called decimal form? Do you remember that rule? Because any number can be put into a decimal. How? By going 0.0 at the end. So any number can be put into a decimal by putting 0.0 at the end. Alicia's still not back yet, Danica. You just gotta wait.
Oh, sorry. No, Alicia's still in the office.
Oh no, Alicia's still out. So.
She's in the office.
Oh right, Alicia had to go to the office. My bad. But Logan's out. So Logan's out. Yeah. Okay. Standard form or decimal form. Okay. Now we can also put any number into a fraction. I could put a 9 into a fraction by going 9 over 1. So every digit can always be put into a decimal or a fraction. Okay. Now the repeated multiplication is also called expanded form. Okay, expanded form. So it's got all the numbers written out left to right. And then we talk about the ones that are commonly used. And that's these ones coming down on the third chart. So we're seeing where they're multiplying. Our base number is 3 in the first case. So our base number is the big number. The baby number, remember, tells you how many of them you see, okay? So in the first one, I see 2 number 3s, so I have a 2 on top. Then I see 3 of them. Then I see 4 of them. That's what it tells you. Now, in our calculators, the exponent button could be written different ways. So we could have this button, whoops, it looks like a teepee sort of, or an upside down letter V. That's an exponent button. Or you could have an X to the Y button, or it could be Y to the X. It's one of those three buttons. So each of those are called the exponent buttons on your calculator, okay? All right, so those are the exponent buttons. The exponent buttons on the calculator. Okay. So now it says the commonly used ones are for the exponent number 2 and exponent number 3. So these two are very special. So exponent 2 is called squared, and it's got the baby 2 up top. And exponent 3 is called cubed and has a baby 3 up top. Now, the reason they're very special is because they are talking about specific objects, actually. Anything squared is actually talking about an actual, real square. So it's actually talking about a square. And how many sides does a square have? 4. But if I were to calculate area would be length times width, correct? Yeah. Length and width, whichever is which, it doesn't matter who's who. But whenever you've got length and width for a square, but they're the same size. So we would usually put little dashes on our lines to tell us they're the same size. So if I've got a square, the first example says 6 squared. So that would mean I've got a square that's got a 6 all the way around it. That's what that's telling me. So if I wanted area for that square, area is going to be length times width. And in this case, using powers, it's going to be 6 squared because I've got 6 times 6. So let me just back that step up a little bit here. I've got 6 times 6, the same number, so I would say 6 squared, okay? And area is always squared. That little 2 means that I multiplied 2 numbers together to get my answer. That's what that little 2 means, okay? So exponent, we're going to write that down. Exponent 2 means we multiplied 2 numbers. And we're going to be more specific than that. We're going to say 2 identical numbers. to get area of a square. And I'm just going to draw a square. Okay, so when exponent 2 actually means something in words to us, so it means we multiplied two identical numbers to get the area. That would be my length times width. Make sure you're writing all these little cheats down that I'm writing in your notes. You got to have them written down. So if I'm talking about squared, exponent 2 means we multiplied, so that's the first thing it means, and it also means we're dealing with a two-dimensional object. Two-dimensional object. That's what we're dealing with, a 2D object. So we call that 2D, 2 dimensions. So 2 dimensions would be length and width, but in this case, they're the same size. Okay, so our length and widths are the same size. So often you might see area written as side squared. So you could often see area be written this way, S squared. And S means side times side. That's what that means. Okay. So that's actually talking about a two-dimensional object. That's super important. So if exponent 2 says I'm dealing with a 2D object, length and width, what do you think exponent 3 tells me? So if exponent 2 is a 2D object, what would exponent 3 be? A 3D object, exactly. So we're going to write that under here. Exponent 3 means okay, first thing it means, we have a 3D object. And it's got length times width times height to give you volume. So 3D objects deal with volume. So with our 3D objects, we're dealing with actual cubes. Our length, width, and height are the same size. So we are actually dealing with cubes. And that does not look like the word cube. All right, we're dealing with cubes. So I'm going to draw a little cube here. Here's my cube. Looks like a little sugar cube there. All right, so this is my 3D object. My square was a 2D object. Okay, so now I've got my length, my width, and my height. And my length, width, and height are all the same number with cubes. So length, width, and height are all identical numbers. Okay, since it's all identical numbers. So the second thing it tells us then is that 3 identical numbers multiplied to make my answer. Okay, so that's what it's actually telling us. Please try and write your notes in. Okay, because remember, when you're going to get some open book time, you want to have these little cheat notes in there for you. So the 3 identical numbers are multiplying to make your answer. So let's just pretend I used the number 5. So that means my length, my width, my height, every number is a 5 on my cube. Okay, so I would say this guy is 5 times 5 times 5, which gives me, 5 exponent, how many?
3.
Yeah, 5 exponent 3. I've got 3 5s. That little 3 says I have length, width, and height, and they're all the same. That's what it says. My length, width, and height are all the same. That's what it tells me about my cube. Okay? So my length, my width, and the height are all identical. And I can reduce it so I don't have to write all those numbers. I can reduce it to a power. Okay, and then we talk about how we can say it in words. So in words, we can say it 4 different ways. So this is how we could say it in words. So if I had 4 squared, that means I've got the area 4 times 4. So what would I say? I would say 4 to the second power. We know that we could say 4 squared. 4 to the second power means the same thing. 4 with exponent 2, and then 4 to the power of 2. So I would either say exponent or to the power of. These mean the exact same thing. Okay? And then second power and squared, they mean the same thing. So there's some words that mean identical things. Okay? So if we were to match the words, these 2 words mean the same thing, and these 2 words mean the same thing. Okay? All right. That's part A done. So now we've talked about powers in general. Now we're going to talk about specifically powers of 10. So that means my base number is a 10. So my bottom number and all my sides of my cubes and everybody is a 10. That's what we're going to talk about. So I'll give you a moment to finish writing that down and then we'll continue. So powers of 10 in scientific notation. Large numbers such as the speed of light, the distance from the Earth to the sun, often are represented in abbreviated forms. Abbreviated means in just short form, okay? Shorter. That's what abbreviated means. So the speed of light is referred to as 3 times 10 to the 8 meters per second. Well, what does times 10 to the 8 mean? Well, if it's a power of 10, the little baby exponent number tells you how many zeros follow the number 1. So 10 exponent 8 would be the number 1 followed by 8 zeros. That's what 10 to the 8 represents. That means there's 8 zeros after the number 1. That's what it means with powers of 10. So we have the number 300 million meters per second. And this really big number, 300 million, is abbreviated to that. Because remember, we talked about what if you're putting numbers in the newspaper. If it's in the newspaper or if it's a post on social media, your posts are based on the number of words and the number of spaces. So that means if you want to make sure that you can have as many words as you want, you've got to abbreviate the other numbers. So you got to make them as small as possible. So we talked about the one in millions, where, for example, if it was 50 million, they're not going to write the word. See there, it's glitching. That's what's going on. So if the number is 50 million, you're not going to write 50 and then 6 zeros. That's going to take a lot of space in a newspaper or in your social media posts. So that's why you would use either a 50 with an M for million, or maybe you'd write millions beside it, but you're not going to write all of those numbers. Okay, you're trying to keep it shorter. So in order to keep things shorter, we use powers of 10. So powers of 10 in scientific notation. So like I said, the number on the exponent, the little baby guy, he tells you how many zeros are at the end of a digit 1. So we look here, it says powers of 10 reduce the size of larger objects into something that we can manage, something smaller. And then it's not going to take up as much space on your page. So the power of 10 is a base of 10. Okay, so your base is the 10. Okay, the exponent number can be any number. And the exponent number, this number, as we said before, this tells us how many zeros are after the digit 1. Okay, so it's going to tell us how many zeros follow that digit 1. Okay, so 10 exponent 2 is going to tell us there's 2 zeros. 10 exponent 3 is going to tell us I have 3 zeros. Okay, so that's what the exponent number tells us. So let's move down. We've got a couple examples here. I've got the number 7,000. So we're seeing the number here in example A. We're seeing the number 7,000. Well, we want to make that shorter. Well, we could say, well, that's 7 times 1,000. And then we're going to make that even shorter. We're going to make it shorter because we can represent this 1,000 as 10 to the 3. So we would write 7 times 10 to the 3. 20,000 is 2 times 10,000. And it would be 2 times 10 to the 4. What about this example? What if I had a couple numbers in there? What if I had the number 6500? What if I had that? Well, this one gets a little tricky. If you've only got one digit, we've got one digit, that's awesome. But this one's got 2 digits that are different from a 0. When we've got 2 digits that are different from a 0, what do you notice that we've got up here? We've got one single digit times a 10 with a power. One single digit times 10 with a power. We could easily write those. Remember, any number can be put into a decimal. I could write this as 7.0 times 10 to the 3, and this would be 2.0 times 10 to the 4. Now, the number on the left-hand side of the decimal has to be between 1 and 9. It can't start with a 0. It's got to be between 1 and 9. So that means, where would I put my decimal? If I'm guessing, I'm going to put my decimal right there. That's where my decimal belongs. So on this one, I would have, well, we could write it like this, first of all. 65 times 100. So that's going to give us 65 times 10 to the 2. But now I've got 2 numbers, because that's like saying 65.0. Is that allowed? Not for scientific notation. So for scientific notation, I'm not allowed to have 2 numbers in front of that decimal. I can only have one of them. So that means I need to move that decimal number in between the 6 and the 5. And when I do that, I'm going to look at my very first number. When I look at my first number and I put that squiggle line in between the 6 and the 5, how many digits are at the right-hand side of the squiggle line? How many digits are over here? 3 of them. There's 1 on the left, 3 on the right. So what's going to happen is, I want to say, well, this is going to be 6 times 500. Okay? So that means instead of 65 times 100, it would be 6 times 500. So that just means I'm going to have one number after the decimal. So this is going to turn to 6.5, and then I put my times 10, but it's not going to be a 2 anymore, because I got to look at my original question. My original question, if I were to move my decimal to the end, because right now, where does your decimal start? If you don't see one, it's hiding, and it's going to hide on the end on the right. And I need to move it in between the 6 and the 5. So how many places did I have to move it? I had to move it 3 to the left. So the number of places you move it is the exponent. So this 3 says I moved the decimal 3 places left. And it's important that it goes left. So we have a hiding decimal on the far right, and I'm moving it left. Okay? That's what's going on. So we're going to do a few other examples like this, and it'll make way more sense. And it's not loading very well for me, so let's see what's going to happen. I'm just going to have to reload this, guys. Play. Come on. Why? Let's try that. There we go. Okay, now we're talking more specifically about our scientific notation. This is using powers of 10 to describe your words, okay? So if we say the distance between the Earth and the Sun is that far away in meters, well, we know this is hundreds, thousands, millions, billions. So that would be 150 billion meters away. That's how far the Earth and the Sun are apart from each other. So how can we abbreviate that? So remember, we would want to move our decimal in between the 1 and the 5. So right now, our decimal is hiding. And our decimal is hiding right here. Okay? The letter M is our units. That's for meters. So the decimal doesn't hide with letters. It hides at the end of a number. So it's hiding right there. How many places do I have to move it to make it sit right there? I need it to sit between the 1 and the 5. So let's just check it out. We're going to find out how many spaces it has to move in order to sit right there. So I would move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 steps. 11 steps left. Okay, 11 steps to the left is where it moved. Well, guess what my number is, my exponent. My exponent then becomes the 11. Okay, so that's what my exponent becomes. It becomes the number 11. So my decimal moved. It moved in between the 1 and the 5. And then I had to put times 10 and then my digit 11. Okay? All right. Whenever you've got a number that says times 10 to an exponent, that's scientific notation. Okay? So let's take a look at what scientific looks like in general. So in general, in the middle of our page, it says you can only have one digit. It's got to be a single digit. So this guy here, it is a single digit.
Always
One.
always? Is that right? Never can there be doubles there?
No.
Okay.
So it's between 1 and 9. The number 0 will never be there because you have to move your decimal over again. So it is always a single digit between 1 and 9. Okay? And then you could have all the rest of the numbers on the end of it. It doesn't matter how many numbers. And I'll show you an example like this in a moment. And then we say times 10, and then we have our exponent on there. The exponent tells us how many places we moved left. How far did the decimal move to the left? That's what it tells us. That's what that little exponent number is telling us, is how far did that exponent go to the left? So now we're going to look at the next number. They wrote the number 1275. Here's my original number, 1275. Okay, that's what it's telling us is our original number. Now, with any number, we always want to put our hiding decimal point. So my hiding decimal point is always on the right. And I know I've got to make it go in between which two numbers? Which two numbers does the decimal have to sit between? The first two. It's got to move to there. So how many spaces does it have to move? Well, just count the number of digits in between. How many digits are in between those decimals that I just drew? There's 3 spaces. There's 3 digits in between. So if there's 3 digits there, your exponent will become a 3. So that's where this guy becomes a 3. Because there's 3 digits in between where those decimals are starting from and ending from. Okay, so starting and ending. Okay, and this is really key right here, this really important first point. There is only one number, a single digit. In front of the decimal, but not the number 0. It cannot start with the number 0. It's got to start with the number between 1 and 9. So it could be 1, it could be 9, but it cannot be a 0. And it can't be double digits. Now you can have as many numbers to the right of it as you want. We're going to do an example here on the bottom. So here's a big example. 840260903. Whoa. That's intense. That's a big one. First thing you're going to do is draw your hiding decimal. Okay? So draw your hiding decimal point. Okay? So step 1. Draw hiding decimal. Step 2. Locate the new spot for your decimal. Locate new spot for decimal. Step 3. Set up your scientific notation. Step 4. Count numbers between the two decimals. This number becomes the exponent on the 10. Okay, so that number becomes the exponent on the digit 10. So write all your steps down first, and then I will do all of those steps with you together. So in our example, we did step 1. We put our hiding decimal. Now it says locate my new decimal spot. Well, it's got to go between the 8 and the 4 because remember, you want to be able to have what? The first number has to be between 1 and 9. 8 is between 1 and 9. We can't have 2 digits there. So now I got to count how many numbers are between. So I've got 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers between. Well, that number is going to be the number on my 10. So now I'm going to write my number like this. 8 decimal, and I have to write the whole number. 40260903, and then we put our times 10, and now I'm going to put my little exponent number. My exponent number is going to be an 8 because there's 8 numbers in between. That's how I have now converted my number to scientific notation. Okay, so what it's telling us is it doesn't matter how many numbers come after the decimal. What matters is how many numbers are in front of it. And the exponent number on the 10 is always the numbers between your 2 decimal points. So you locate your hiding one, then you locate where it should go and count the numbers between. Okay, so if I'm not sitting right beside you, and if you didn't write those little hints down, this is how you would do it longhand. So what we would do is I would see I've got 3 numbers. I would put my first decimal point in. I'd put where he goes. How many digits are between those 2 decimal points? 3. So what do you notice? 3 digits between my decimal, those 3 digits. Well, I have a little exponent 3 there. Okay, and that's all scientific notation is. It's writing your numbers a little bit shorter, okay? So, whichever way you find the easiest to remember it, these are showing you longhand how to do it, okay? So it says some people call it moving the decimal point. That's what we just did. Okay, moving the decimal point I find is easier and less confusing. So that's the way we're going to stick with in this room, okay? All right, so they're showing that, and how could they do it? We're going to go to the top of the next page. Let's see if you can figure out A, 4,000. So 4,000 in scientific notation is going to look like this. So we got to write our hiding decimal. Whoopsie, wrong color. Write our hiding decimal. Put where he belongs. Okay, and now count how many numbers are between my decimals. I've got 3 digits between my decimals. So I've got 3 digits between. That ends up being a 3. I've got 3 numbers between there. So that's what's going on. Let's take a look at B. So B says I've got the number 3 million. Well, if I've got the number 3 million, I've got my hiding decimal point there. I've got where it should go is right here, because I can't start with a 0 and I can't have 2 numbers. So now I count how many numbers are in between it. And I see I've got, in between, I've got 6 numbers. 6 numbers between. And what did we notice those 6 numbers between became? Those became our baby exponents. So 6 numbers between became the 6 on top. Last couple examples. So letter C, 345. Again, we're going to draw our hiding decimal. Oh, darn it, I'm in highlighter again. Hiding decimal, put where it goes. He's supposed to go between the 3 and the 4. How many digits are in between there? 2. So I have 2 numbers in between. That means I'm going to have a 2 on my 10. That's all it tells me. Okay? So 2 numbers between my decimals. Here's a bigger one. Look at D. It's really big. So you have a 5-digit number there. And again, it doesn't show us a decimal. So we have to write our hiding decimal. Once I write my hiding decimal, now I got to find out where it should go. It should go between the 1 and the 2. Now I count how many numbers are between those 2 decimal points. I have 4 digits between there. So that means my little exponent is going to be a 4. Now, you're going to notice they didn't write all of these numbers. What did they do? They rounded it to 1 decimal place. So they rounded this number right here. And the 0, remember we talked about rounding? How do we know if a number is going to go up or down? Well, if a number is 5 or bigger, we're going to add 1. And if it's 0 to 4, it stays the same. All right, what is that number again there, buddy?
14,532,739.
Sounds good. All right. First thing we're going to do is we are going to put our hiding decimal. Now I want to put my decimal where it belongs. Where should it go? Which 2 numbers does it have to sit between? What do you think?
32 and the 73.
It's only going to sit between one of them. And it's got to go as far left as it can.
14 million.
It's going to sit between the 1 and the 4, yeah. So it's going to sit right there. So now I count how many numbers are between my decimals. We got to count the number of digits. So I've got 3, 6, I've got 7 numbers between. Okay, so if I've got 7 numbers between, I know my number on my 10 is a 7. So I know this already. I know times 10 to the 7. That's what this is telling me. I have 7 numbers between. Now, what number do I write first? I write the original number with my decimal moved to the new spot. So my number is going to be 1 decimal 4 5 3 2 7 3 9. Now, if we wanted to, we could have done what the question above did, and they rounded it to the nearest 1 decimal place. So if we rounded to the 10th, I could do the same thing on this question. So if I said to you, I want to round this number. So remember, when we're rounding, we look at the number to the right. Okay, look at the number of the right. So I'm looking at the 5. What is the 5 going to make the 4 do? Anything? Is he going to stay a 4 or is he going to add 1 and become a 5? What do you think? He's going to add 1. You're exactly right. Anything that is 5 to 9, you're going to add 1. If it's 0 to 4, it stays the same. So my rounded answer is going to become 1.5 times 10 to the 7. So now what we've done is we've added every single rule that we've done so far. We've added our rounding rules, we've added our place values, we've added our powers rules, and now we're adding our multiplication rules. So this concludes lesson 1.6.